speakers for the meetup, and I hope you guys enjoy it. This meetup is divided into like today and tomorrow, and we're gonna be going live on the both days at 9 p.m. IST, Indian Standard Time. So yeah, so I'm just gonna. So I have prepared a few slides for the audience. So I'm just gonna go through them. I hope you can see it. So, like, first of all, what is PyData and what is NumFOCUS? So, I'm sure like all of you must have used Pandas, NumPy, Matplotlib, and all these open data source tools which are present online. So basically, NumFOCUS is a 501c3 nonprofit in US which supports all these data tools, and they provide funding, they provide sponsorships, they provide developers, and everything which is necessary to keep the projects alive and sustainable. And PyData is educational initiative by NumFOCUS, which is a community for developers and users of open source data tools. So there are like 160 plus chapters all over the world, and PyData Delhi is currently fourth largest chapter in the world, and we are proud to say that because we've come a long way. And yeah, PyData Delhi started back in 2016. Since then, we have organized like 35 plus meetups and 3 conferences. So yeah. So Meetup is live streaming on YouTube. You can go to this link and it will be redirected to our live stream. And so I'm just gonna do a small introduction for our speaker today. His name is Deven Desai, and he works at Planet Labs. So he's leading product. He's a lead of product over there, and he would be speaking about making satellite imagery useful. And so yeah, more of that in the upcoming few minutes. Yeah, so where to ask questions? So obviously, like the talk is going to be pretty interesting and exciting. So I'm sure you must have all of you must have some questions to ask. So you can just put the questions in the YouTube live chat, and we have like volunteers all over the place who would be noting down your questions, and we would be asking them at the end of the event's talk. Yeah. Yeah, so obviously, like we have a code of conduct in all our meetups and conferences, and it is imperative that we should stick to it for this online version of Meetup also. So it's not something like you should have to read it twice and thrice. It's just that you have to be nice and please ask relevant questions and do not spam on the YouTube live chat because that is not cool. And if you want to read the full code of conduct, it's on the delhi.python.org/coc. You can just go to the link over there. I mean, after the meetup, of course. Yeah. So, I mean, I hope this pandemic would end as soon as possible. So after that, we're gonna resuming to our physical meetups, which will be happening all over the Delhi NCR. So if you want to propose a talk for the meetup, or if you want to give a talk online, so because I think we're gonna have the next meetup in this format also, and if you have like if you want to speak on something and if you have an interesting idea, so you can definitely go over to this link and you can create an issue over there. So yeah, just please note this down, and we will also be sharing the slides, so you can just take down the relevant links from there. Yeah, where to find us? So yeah, we are omnipresent. We are everywhere. So you can just check out our Twitter, Meetup, and everywhere we are with this handle PyData Delhi. And so we have a cool image of this Illuminati placed by one of our volunteers, Chetan. So yeah, so perfect. And yeah, so we also created a public community calendar on this link. So you can just go to that link and you'll automatically get subscribed to our Google Calendar. So we post all of our meetups and all our events over there. So you can just have a look at that. It's a pretty funny, it's a pretty good thing to use, and it'll come handy. So yeah, I think I'm done, and I've taken almost like 2-3 minutes. So I'm just gonna start with Devin. So yeah, Devin, over to you.
All right. Hello, everybody. Can everyone hear me?
Yes, I can.
Okay, cool. Sounds good. I'm going to start sharing my screen. Let me know the moment you get to see the presentation.
Yes, I can see the presentation.
Cool. I'm going to go full screen as well.
So Devin, why don't you just introduce yourself a little bit first? That would be good.
Yeah, for sure. So a little bit about myself, just to correct Sanket a little bit, I don't lead all of product or anything at Planet. I'm primarily responsible on the go-to-market side of things for a variety of like verticals that Planet focuses on, as well as a few initiatives as well. So when it comes to imagery, my main focus is on making sure our high resolution data is useful for any customer that wants to use it. When it comes to actually building stuff on top of the imagery for specific verticals, my main focus started with energy, kind of bled into insurance a little bit, and right now it's mainly to focus on small to medium-sized businesses who might not really fully understand how to work with geospatial data, to evangelize them, make sure they understand how to use it, and also create packages and pricing that's important and accessible for all those companies to have. Now, all of this can be done without really having an engineering or a product background, but it's super helpful, especially when you're working in a small company, to really be able to understand the nuances, so that when you're discussing unit economics, when you're discussing the entire product development lifecycle or whatever, you have a bigger picture in mind. So that's kind of where I fit in. And this presentation is going to be kind of a primer on making sure that everyone here kind of gets to see kind of the general way we go about building a product or something at Planet. And it also will kind of weave into the tapestry, the history of what Planet's been going through in our journey to even provide the first pixel to a customer, right? So that's kind of what we're going to do. And if I was to be 100% honest, I kind of lied to everybody, because making satellite imagery useful is a pretty boring title. That wasn't meant to be the title, and I did it on purpose, because lesson number one is under promise, over deliver. So the actual theme of today's discussion is you can't fix what you can't measure. And in general, you can't measure what you can't see. So we're going to have to start at the beginning, because at least the way the company started, I certainly didn't found this company. I joined about 3.5 years ago. There were a lot of open-ended questions, like how do you even start to solve a problem like imaging the entire Earth every day, which, by the way, was the first mission of Planet. How do you even go about making sure that all the stuff that goes into operating a satellite network and then eventually building the APIs to give it to customers works out? That's kind of not how the company started, right? The company started in a very first principles approach of just let's figure out the first bit of problems, go from there, and then move forward. So this talk is going to be about a first principles approach in practice to vertically integrated product development. And that's just a huge mouthful way of saying that we're just going to start all the way at the very beginning. And so let's start at the beginning. Before Planet, the concept of a CubeSat kind of stayed in the R&D side of the world. Believe me, there were a lot of CubeSats before Planet came through. The notion of what a CubeSat is also a fairly defined thing at this point. It's 1 10 centimeter by 10 centimeter by 10 centimeter cube. And so all of these satellites that you see here, which I'll talk about in a second, are all 3U CubeSats, because there are 3 of them put together, kind of in a loaf of bread situation. So, the main question was, can we get off-the-shelf parts that are just lying around to build out a satellite that could work in space? And the answer is yes. And in fact, in the top left corner here, you'll see the first iteration of what was built. And then, since then, the company might have coined the term agile aerospace. I like to put it in quotes because agile kind of gets overused way too much. But in the context of aerospace, and the context of hardware more broadly, agile is still a fairly unconventional word. So I like to define it, and we, as the Royal We Planet, like to define it by making sure we continuously iterate on our bus, which is the mainframe of the satellite. And we also try to make sure that we improve each and every single component, in a routine manner, probably every 3 to 6 months, so that every single time we're doing a launch, and believe me, we do a launch probably on average every 90 days, there's something new about the satellites. And if we need to test something, then we need to test something. So if we were to roll all the way back out to the very first satellite or the first few satellites, how do you test that they're actually going to work? You can do a few things, kind of silly things, on the ground. So the first, test to understand shock and, to understand vibration was basically taking the satellite to the top of a balcony of the second floor and dropping it onto the ground to see if it can resist a few G's of shock. But that's not really going to do it. You actually do need to go to space. And so nicely enough, SpaceX does let you put on the tippy top of their big rockets, like this part right here. Hopefully you can actually see my mouse. The ability to add a secondary payload. And so that's what we did. This mission, particularly CRS-6, was one of the first missions which took up our first few satellites. But you can't just kind of send this stuff to some random place in space. You got to send it somewhere to test it properly. So where did it all go? Well, thankfully, NASA allows a bunch of research satellites to be deployed from the International Space Station. And so this is kind of like an iconic photo that was taken by an astronaut that was in the International Space Station as they were deploying the first few satellites from the ISS. And so the launcher that you see there is provided by a company called NanoRacks. And so it's used by not just Planet, by a variety of other missions that are out there as well. But these are one of the first few satellites that got deployed. And while this is an image that's kind of cool because it's primarily black because of space, this kind of is an indication that we like to test things, and we like to test things early and often. But what happens once you've finished the testing, or rather you've tested enough to know that you can go to production? Like production for us and the production deployment back in the day literally meant going to space. And so we had to build out an entire infrastructure. Imagine that they were just like fancy little expensive Lego parts that you're putting together in an assembly line manner, right? And so we are trying to build these satellites in mass. We're trying to make sure that these things are standardized as much as possible, that we test them on the ground as much as possible. The supply chain is good, and we can just repeatedly keep producing these out. And back in the day, we didn't really have a dedicated manufacturing space. Now we do. And so what we're able to do is we're able to just tag them, pack them. We put them in a large wooden pallet, and then, it gets shipped over to random parts of the continent because, launches happen wherever. But at the end of the day, you need to ship them. And one of the big launches we like to talk about is this particular launch, the one that happened in India. This was the world record launch that ISRO did with C-37, if I'm not mistaken, and that was with 104 satellites at one given time. So one or two of them were Indian satellite missions with Cartosat-2, and all the other ones were private satellites and commercial satellites and research satellites that went as secondary payloads, even though they represented the lion's share of the weight of the payload. This is important because 88 of those 104 satellites were Planet satellites, right? This was a huge bet the company took. We actually, brought over 20 satellites that were meant to be manufactured for a later launch and pulled them back into the ISRO launch to see if we can get more to space quickly. And thankfully, that bet paid off, right? But at the end of the day, like all this rockets and, aerospace stuff is interesting, but at some point we need to talk to them. And so now the next challenge for Planet was, okay, how do we build out infrastructure to talk to them? We started with, one single dish, at the Stanford campus, called a Stanford dish, but that wasn't going to be scalable. And frankly, with the orbit patterns that we choose, which is called the sun synchronous orbit, which is really close to the north and south poles, so that we're able to capture imagery closer to noon, but a little bit off. So one constellation tends to be at the 10:30 a.m. plane, and then the other constellation tends to be at the 1:30 p.m. plane. And so in order to talk to satellites at those two orbit planes, you need to build these kinds of ground stations. And yeah, we slap the shit out of art on everything that we do, including our satellites. So you see a nice, pretty ground station set right here. There's about 45 of these all around the world. And we had to go off and build these, right? So these are in the middle of a farm somewhere. Most likely they're in super high or super low latitudes because they need to be closer to the poles to give us as much line of sight as possible, to capture as much data as possible, as quickly as possible. I'm going to start saying possible a little bit less now. But basically, you need to commission the satellites, right? And so it's a lot of stuff that has to go through just to make that happen. But then, you know, you got to manage and maintain those satellites. We don't have like a team like NASA where, like, you know, those fancy movies that you might see with Apollo 13 or whatnot. A mission control is like 50, 60 people on one shift for 8 hours and then rotated 2 times over with 24-hour coverage. We don't have that. We're a tiny startup, relatively speaking, when we're trying to do aerospace things. And so a big thing that we do at Planet is we automate all the things. Anything that can be automated is going to be automated. And so that's the only way we're going to have to be able to, you know, we're going to be able to maintain 200 plus operational satellites in space. We can only afford to have a handful of engineers to maintain them. And so this particular room is in the Mountain View office that we used to have. And these are all the folks that maintained the high resolution satellites. And so eventually, you know, the same type of function is copied over for the missions team that does the medium resolution, and now everyone's moved over to the San Francisco office. But this kind of illustrates to you that like a handful of engineers who aren't, by the way, working 24/7. Yes, a few are, of course, on call, just like any other software engineering team. But all these satellites just get maintained by themselves. And so that's kind of how it works. But, you know, it kind of lets you do cool things. I hope this video works. I'm actually going to pause it so that the stream can match where I'm at. We'll give it a couple of seconds. There it is. So it does look a little jittery. It's supposed to be a lot smoother, and I'm happy to share the YouTube link because it's a public video. But you can do cool things when you have a lot of satellites in space. Chiefly, you can take photos in a very high frame rate, also known as a video, of a rocket that's launching with more of your satellites going to space from satellites that you already have in space. And so this is a rocket launch that happened with the Soyuz that we captured from satellites in space. And I am noticing a lot of jitteriness in the YouTube stream, and that is not nearly as cool as it would have been otherwise. But it's okay. I'll send out the YouTube link for this to Sanket and the PyData Delhi team, and they can go send that out afterwards. But yeah, it's interesting, right? But at the end of the day, like, what the F does this all mean, right? Like, all of this, at the end of the day, is kind of just space stuff. It has nothing to do with helping build imagery products that help customers make decisions. It has nothing to do with like making money for the company. In fact, all we've done so far is spend money. And so how do we actually get to a place where we're making all of this stuff useful, right? Like, what's even the point of like launching all of these satellites if we're not going to be able to make them easily accessible to as much of the population in, I guess, the world as possible? You know, where, Deven, is all the imagery that, you know, you've been mentioning to us, except for all of these fancy slides? And so a big part of what needs to happen is not so much that we just talk to the ground stations, to the satellites, and then downlink all the data. All of that data actually needs to be processed, right? And so at Planet, you know, we until recently maintained 3 constellations of satellites. We had the PlanetScope satellite. We had a Rapid Eye constellation of 5 satellites as well, which we had acquired from a German company, which was then a Canadian company, which was then us. And then SkySat, which is the constellation that we acquired from Google, which Google themselves acquired from somebody else. And so, like, all of these 3 satellite constellations are producing an immensely large amount of imagery, and so they need to be compressed and downlinked to our ground stations. But after that, we have an automated data pipeline that, you know, creates basically a distributed compute system that processes all of this data and makes sure it's in an archive, because per NOAA, which is the National Oceanic Atmospheric Administration, restrictions, we have to archive everything that comes down to space, or comes down to Earth, sorry. And so a large part of what needs to happen here is we need to be able to reliably produce the imagery, publish the imagery, index the imagery, archive the imagery, and then make all of that available through a catalog or a series of web tile services to our customers, right? So a huge work went into that. And we only got to this point because we were able to successfully deploy enough satellites to then produce enough imagery, to then make enough ground stations, to then get that imagery onto the ground so that we can actually process the imagery. So like this was a multi-year thing. And so, while we're very fortunate that, we're in the Bay Area and a lot of venture capital companies have a fairly longer trajectory and an investment cycle that they want before they see a return, we're pushing it, right? So we need to be able to produce data as soon as we have it as quickly as possible. All the more reason why this automated data pipeline is very important. So all of that culminates this entire ramble into this one slide that you're about to see in a second. It's really noisy, and so I'm just going to skip it in a second. But basically, the TLDR is we have a lot of launches, lots of area covered, lots of images for any given point on Earth. We do a lot of downlinking. We have a lot of data. We have more data, I think, than most of the customers that Google Cloud tends to have on their roster. We're pretty much, I'd say, in the top 5. We've got probably about 10 petabytes of data. And, I'm glad Matthew is on the call as well from Netflix, because I'm pretty sure Netflix has a pretty damn heavy library as well. But, this is not, a small amount of information for anyone to work through. A lot of this needs to become useful. Most of it is not going to be useful, but that's not the point, right? The point of a catalog is that even if only 0.5% of this data is useful, it needs to be in a manner that is easily accessible at any time, anywhere, because any point of that 100% is going to be useful for anyone. And that 0.5% might be different for a whole bunch of people. So in this case, what you're seeing here is a company called Vulcan Space, and they are part of the Paul Allen Foundation, who are trying to not just map, but classify all of the different species of coral that exist in all the coral reefs in the world. And so it's this Coral Atlas project that's been going on for a couple of years now. Planet's been super, fortunate to be able to support it. They're an excellent commercial customer of ours as well. And it just kind of goes to show, like, this is simple stuff, right? And, in the news, you might have heard that, coral reefs are dying and there's bleaching happening everywhere and stuff happening in South China Sea. But a lot of that stuff is still at a very platitude level or at like an anecdotal level because people have seen the destruction. But it's really hard to empirically calculate what's actually happening. And there are lots of researchers around the world, not just at Vulcan, but at universities, at marine biology institutes that need to be able to make better analyses and better empirical studies, publish those papers, and then eventually get to a place where it goes to policy to save these freaking coral reefs. A lot of work needs to be done, and a foundation of that is a part of that is this habitat classification of making sure you understand at an empirical level and a quantifiable level what's going on with these coral reefs, right? So that's one thing on the humanitarian side. Like, I guess another thing is Google happens to be an investor in Planet. It also happens to be one of our bigger customers, and they also provided us the high resolution satellites because we bought that constellation off of them. Well, one of the things they do here in India is, especially during monsoon season, there are a lot of floods. And so in certain key areas, especially where there are distressed communities and villages, they try to do as much flood modeling as possible. And they use Planet data both on the high resolution side or the medium resolution side in order to understand the impacts and varying degrees of flood patterns that could occur based on different models of precipitation that occur throughout the course of that monsoon season. So this is pretty important information that needs to be given out to people as quickly as possible during a monsoon season. And you can see that the last mile approach, the actual notification, the early alerting, the most important part, I'd argue, is something that Google's handling, right? It's not something Planet's handling. And so a big part of what I wanted to share here is Planet's not solving all of these problems. And in fact, it'd be kind of ridiculous for us to think that we would. We want to make sure our partners, customers can actually do this kind of stuff, whether it's commercial, humanitarian, or whatever in nature. They're the ones that are actually in touch with their customers, their constituents, if they're on the governmental side, and they need to be able to make good decisions. And all of those good decisions rely on really good data. So at Planet, we've got about 4 types of main product segments, if you will. One is the daily monitoring side, which is taking all the raw data that we have coming in from all of our satellites, polishing it just a little bit to make sure that it's accessible and nicely indexed and all the metadata is queryable, and then just pushing it out into a catalog. The next abstraction layer on top of that is the concept of a base map, which is effectively a composite of as many of the pixels as possible for a given time frame. So in this case, a month or a quarter, sometimes a week, but let's just focus on the monthly and quarterly side. And this is important because like sometimes you just need to not have the most temporal intensity, but you need to have the best spatial accuracy. And you need to be able to have the least amount of noise introduced as possible in order to make some kind of decision. We'll get into that in just a little bit. Frankly, that's going to be the thing we're going to focus on for most of this talk. But the other two that we're going to discuss is the high resolution side of things, which basically lets you task one of our high resolution satellites. They're not just constantly imaging the entire Earth every day. That would be impossible for 15 satellites to do. That's more of a job for the 200 satellites to unbiasedly image every day. So for the high resolution constellation, we want to make it as easy as possible for people to task our high res satellites. And then all of this, geospatial data needs to be abstracted even one layer further by doing a variety of analytic feeds. And so, naturally, the first two that we went out to market with were road and building detection, super useful. Sorry, I'm going to drink some water here. Super useful when it comes to understanding how road infrastructure is being built in developing nations, the delta of private property, road construction and infrastructure build out versus public property, making sure the censuses are updated. So this is all surprisingly fascinating stuff, but we're going to start with base maps. And with this video that you're about to see, and it's nicely convenient that I got to drink some water because there's a little bit of lag with the YouTube stream. I'm just, give me a second. Perfect. So I'm going to have to stop and pause in this video for a little bit because A, the YouTube stream is a little bit delayed, and B, this video kind of goes through really quickly. So this is Peru. And I'll wait a little bit here before I go ahead and start my spiel. There we go. Okay. This is Peru. And at the end of the day, what that means is we wanted to be able to understand what the annual forest coverage was for this country, right? This is a pretty large area size. It's got a lot of different topographies, as you can tell on the coastal sides. There's a lot of ranges. But on the eastern side of Peru, there's a lot of forests. And so we got to get ground data. So we worked with Arizona State University here in the United States, the ERAL Foundation, and a few other institutions in order to create ground truth based on LiDAR collections. And so this is basically that same LiDAR sensor you might have heard about, all the smart vacuums that are being sold, or inside a self-driving car in order to better spatially create a point cloud to make better driving decisions. That same LiDAR can actually give you really good surface precision of ground coverage from air. And this is roughly flying about like 1 or 2 kilometers above the Earth's surface, not 1 or 2 kilometers. Yeah, 1 or 2 kilometers, yeah, above the Earth's surface. Very low altitudes, but with really high spatial accuracy and really good understanding of leaf coverage, foliage, canopy, distances, and all that fun stuff. And eventually, what it needs to be is this level of LiDAR collection as ground truth is fine, but you can't scale it to the whole country or to the whole world. And that's where Planet space maps kind of come in. And so what we wanted to do is prove empirically with a decent sample size of data, so it's a lot of data that we covered, all of the surface reflectance data that we can produce, which is effectively the kind of like light that is reflected up on the ground. So all the atmospheric noise is removed, all the aerosol data is removed, and we're trying to get as much clear of a picture on the ground as possible. Can we take our surface reflectance base map and map it and mash it with these LiDAR collections to actually show in a time series or even between 2 time periods destruction in forest? And can we create a slightly more
hello, Deven. Sorry to interrupt you. Can you please
Yeah.
just slow down the speaking pace? I'm getting questions from all the viewers that your speaking pace is too fast.
Okay, no problem. Yeah, happy to slow down.
Yeah, sure.
Yeah.
Thank you.
Yeah. So the way to think about this, right, is carbon map, and I will definitely go slower. Sorry about that. This is trying to create the accuracy of all of the carbon density and carbon storage at a 1 hectare level, which is much more accurate than what you saw before, which was at the 30-meter level. So try to imagine, making a entire measurement of 30 meters and then a measurement of like just 1 hectare, it's a very different spatial size. And that kind of lets you understand more accurately the way things are happening, especially in a country like Peru, where there's a lot of remote areas of forest, where there isn't that much monitoring that's going on. There might not even be that much road infrastructure in order to understand, what is happening within this part of the country versus that part of the country. So as you really try to figure out what's going on, we're going to zoom into one portion of this entire map. And what this is going to show you in a flicker back and forth is forested area that's been removed. So you'll see a lot of green patches that will be removed, and then it'll come back because I'm flipping back between 2 time periods to be able to show you the delta of the amount of forest loss that's happened. And all those squiggly lines that you might see, those are basically rivers. And so naturally there isn't any vegetation in rivers. So as you see this, if we were to highlight all the changes that happened, those changes are areas of forest carbon loss. And that is quantifiable because now we can actually spatially put more layers on top to bring context to why this is important or why this is okay, or worse, why it's not okay. A lot of times mining activities occur near river sources in Peru that are permitted, and a lot of times that are not permitted. A lot of times deforestation occurs for a lot of agricultural reasons because it's much easier to cut down trees and build a pasture to raise cattle and then sell the cattle because it's just a lot more lucrative for a company or even a smallholder farmer, right? So it's no fault of their own. They're trying to create economic security for themselves. But there are rules to follow, and there are places where it can and can't be done. And so to understand this damage that's occurring at such a fast enough cadence is very important. So for that, it's really, 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 really important that we can actually do this at a country-wide level. So this entire study was actually published, I'd say, a year ago. That covers the entire country of Peru, talks about how spatially and how empirically we can accurately determine the loss in carbon storage across the nation of Peru. And while the nation of Peru is interesting, we got to talk about how we got here, right? This was just purely the full procedure in a video, but let's break it down. So why did we even do this? Like, the problem was defined, lots of deforestation activities happening. I'm sure you've heard in the news recently that Brazil had a lot of forest fires that have occurred. So this was becoming quite important. But trees, unlike crops, they take forever to grow, right? And so while a lot of planets' satellite data is important for agricultural context, they're also good for forestry context. And trees, while they're super easy to chop down, the supply chain to transport still takes time. And if you were to expand it out to a larger forested area, we're talking weeks at scale, right? And so countries, districts within countries that are doing all these permitting decisions, they're making these decisions at an annual or quarterly basis of revisit. They'll say, okay, we've been giving out these many permits for the last quarter, maybe we should ramp it down. Or we've been giving out not enough permits over this quarter, maybe we should ramp it up. Where should we give more permits and where should we not? Where is there too much indexed amount of foresting activity happening where there is not enough? Or where are trees growing better off and where are trees not? So reliability is key, right? And there's no room for errors in any way, shape, or form. Or worse yet, cloud cover. And if you don't believe me, this is a public satellite constellation called MODIS, and this is a day snapshot of the world. Most of it is covered in clouds. And there was another satellite constellation called ISAT, another NASA satellite, which also empirically proved that about 70% of the Earth's atmosphere is covered in clouds. So in some way, shape, or form, it's really, really, really hard to deal with clouds for any optical imagery provider. And so Planet definitely has that problem dialed up to 11 because we just collect more imagery than anyone else out there. But it's very important that we actually deal with it. And so the big question then becomes, how do you composite all of these pixels together? how do you make it so that the snapshot looks as clear as this fancy marketing slide that you're seeing right here, where there's a clear delineation boundary of agricultural activity that's happening, deforestation activity that's happening, and then there's forested land near the Iguazu National Park in Brazil that you can't touch, right? And unfortunately, even some parts of that national park are actually getting destroyed, but that's a different story for a different time. But you start with that distributed compute system. And I'm not joking when I say that we have 33,000 spot instances running at any given time, right? Like this is a massive distributed systems infrastructure that runs, and this job system not just runs the mosaic jobs or the compositing jobs that we talked about, it runs everything. It runs how to process all the data up front. It runs the jobs to rectify, also known as the ability to orient imagery to the right locking point on a two-dimensional projection. So when you're looking at two images from yesterday and today, there isn't like a jagged change. Everything just nicely puts right on top of each other. That's really complicated, and that's really hard. And so this job system was built to be flexible. It was a distributed compute system that is normally optimized for concurrency, and that's optimized for doing small amounts of work very quickly. So how do we know that all this imagery is going to be produced reliably? We can't just wait for all of Peru to be done and then kind of check it, right? So in general, as we start building out larger area mosaics, we need to monitor all this stuff as much as possible. And it seems obvious, right? And especially if there are any software engineers that are actively working in industry or in corporates out there in India, like you already know that this is normal. But again, like it goes with the theme. You can't see what you can't measure, right? And so here is just a very small snapshot of a very small monitoring infrastructure bit that we put up in SignalFX that just talks about the job system. We have so many more of these dashboards that are up and around in the office. Alerting is based on this. We have a lot of tools that make sure that anyone who is on an on-call rotation quickly gets alerted when 2 or 3 issues occur, when there's high levels of volatility, and a variety of other use cases. So now that we're able to do that, the problem with Planet is once you deliver it successfully once, you got to be able to do it frequently, right? And so now we're supposed to do this at a global scale. This means we do it every quarter, we do it every month, we do it every season without fail. And this is just the base maps that we're talking about. Remember, this is just one of the 4 product lines that we talked about. And while that Peru use case was nice, where did it actually lead us? How did it actually impact anything when it comes to commercial stuff that Planet does? Well, the United Nations FAO actually put this practice into effect, right? And the thing is, they signed a massive commercial deal with Planet to monitor the forest activities in 8 countries to start with. And this, for the record, is a pilot project. So if this is successful, it's going to expand to even more countries. But the fact that we can actually do this actually drives payouts, it builds good policy, and more importantly, it protects people, right? Because we need to make sure that as deforestation activities occur around the world, that it's not disproportionately negatively affecting members in developing nations. In Indonesia, for example, it is wildly so much more profitable, or Malaysia even, to cut down forest and create palm trees to then make palm oil. And so any palm-related products that you might have, well, like palm oil in itself is not really that bad. It's really more the deforestation activities that occur in Indonesia. And Indonesia is very much rightfully reasonably okay to do it because they're just trying to make economic security for their people through no fault of their own. But it's impacting the global system. And instead of having conversations at the political level with no empirical data, it is much easier to have these conversations when you can actually build a policy related to deforestation that can be accurately at like a sub-meter level be determined. And that's kind of where Planet helps. So, like I said, I only wanted to talk today about one of the 4 things that Planet kind of builds out in terms of product suites. There's a lot of other cool stuff that Planet does. There's one thing that we've been working on for a while now, and we want to roll it out at some point this quarter to most of the world, and that is a tasking API and dashboard. This is literally an API with direct access to our high-resolution satellite infrastructure. And it also comes with a GUI that lets you pick a point on a map and basically say, I need a high resolution image of this like stat. And so imagine being able to have a satellite fleet of 15, soon to be 20 satellites in space for yourself, for your own use, right? And so we've been lucky at Planet that we get to do this pretty much on a daily basis, but we want to make sure that we can, make this easily available to customers out there as well. And this is a problem because this might sound silly and ridiculous, but right now, if you talk to any commercial imagery provider, I'm not sure why you would do that, but if you ever were in a position to do that, you would know that you need to either email someone, or you need to be able to like get on a phone with an account manager to say, hey, I'm sending you a CSV file with a list of lat longs. Please put those into your satellite constellation and get me a high resolution image as soon as possible. Like that is how that conversation goes. And I'm not even joking. And so the reliability isn't there. There's no transparency back to the customer normally about, where in the state management is the status of your request. And so we decided, screw it, let's just automate the whole thing and let's just put it out there so that it's easy for customers to be able to access this kind of information. And so if I was to end with anything, it's really not so much an advertisement of Planet. It's actually a broader statement about how this data is used. This data is normally part of a comprehensive approach, right? There are other commercial providers out there and non-commercial providers. I'll talk about some public domain information in a second. There are a whole bunch of platforms like the Esri ArcGIS toolkit, as well as QGIS if you want something more open source. That is, to me, effectively Photoshop for geospatial people, but it's really good. And it lets you do a lot of analyses very quickly. There's other kinds of data out there. There is government-provided geographical data. There's government-provided or private institution-provided geophysical data when it comes to cloud cover, when it comes to temperature variations, meteorological data, vegetation data, right? There's other sources that actually create hyperspectral data, which literally is not just red, green, blue, near infrared maybe, but rather lots of red bands, lots of green bands, lots of blue bands, all very tightly splashed together so that you can understand variations and pixel changes a lot better. And so work with multiple data sources, I think, is the thing I'm going to try to tell you. If you want to visualize time series, if you want to analyze change in any meaningful way, and if you've got like workflows that you have that frankly might not be starting or ending with satellite data, but might have a small component in some place, you need a whole bunch of other data sets and layers to contextually put together the best picture possible. Planet might be a part of that. There's a whole bunch of other providers out there that are also going to be a part of that. And the more important part is let's make sure, that you get to make the right decisions. And my job is to make sure that we build the right products and services for you to be able to get to that decision a little bit faster. So you pay me money and my company money. And so if we were to, go down to this, this is a fairly engineering-oriented discussion. So if you wanted resources on how to understand how to build any of this information, you can go to developers.planet.com. You'll find a ton of resources there, not just to work with Planet data, I promise you, even though they use Planet information. It still just runs on the generic GeoTIFFs, but geospatial data in general, right? So this tutorial is simply teaching you how to run something called a normalized difference vegetation index. It's an index that's statistically calculated using the near infrared channel and the red channel on any satellite image that comes through to be able to understand vegetation growth, to be able to understand either crop or forest health. A large chunk of what you saw in that Peru study and what the UNFAO is doing is largely based on this index. And this is one of the more generic indices that are available. There's a lot more complicated ones that you can do with a lot more other accuracy measures that actually get defined. But this is just a really good tutorial to let you understand how to use like Python 2 or 3, whatever you want to use, Rasterio, NumPy, Matplotlib, and just start working with geospatial data. Otherwise, there's also, I'm actually going to wait a second. There's also notebooks available. So if you go to github.com/planetlabs, there are a variety of notebooks that are available to the public that kind of go through converting not just Planet data, but other kinds of data into different kinds of calculations. So this one, for example, is going through our analytic data to see if you can change the radiance values, which we provide to you, to reflectance values at the atmospheric level. And so it kind of goes through an explanation of why this might be important, why you might want to care about it, why it impacts downstream calculations, the dependencies that you're going to need to have in order to actually run this notebook, and then it just kind of runs through the entire notebook to let you understand step by step what's going on. Everything from downloading data, extracting the data, saving the image, modifying the color scheme, and then eventually getting to a point where you see a nice, reflectance-based image. So it's a really great way and a really good use of notebooks to be able to not just showcase to you tutorials, but to give you kind of educational context as to why you might want to do something in between each and every single one of the snippets that run. When it comes to public domain data, there's a lot of stuff out there, right? For free, everyone in the world, not just Americans, get access to Landsat data. That's public domain information that's available with a 14-day revisit, which means it covers the entire Earth every 14 days at 30 meters per pixel. And while you might notice that that is one of the less, finer resolutions out there, the Landsat program's been around since the 70s, right? So there are decades of data available to you if you want to run any kind of meaningful time series, if that's of interest or research to you. MODIS is something that we discussed with the organizers here right before we got started. VIRS is another satellite constellation and sensor that got put up by NOAA, National Oceanic Atmospheric Administration. And they have a couple of ways to think about it. From an optical standpoint, meaning images that you see, like here on the right-hand side, they have a twice daily revisit, which is super fast, but it's super coarse. It's at about 250 meters per pixel optically, and it goes up to a kilometer per pixel on certain bands. And then there's also a thermal data that comes through in the source of heat signatures at 750 meters per pixel. So coarse stuff, but because it happens so frequently, it's very useful for understanding, growth in terms of forest fires. Where are wildfires that randomly spun up, right? So those are the kinds of things that MODIS and VIRS are useful for. Sentinel, which is the European Space Agency's version of Landsat. It started out about a decade ago. They have optical data with about a 5 to 7 day revisit at about a 10 meter per pixel. You can imagine that this is a much newer satellite constellation, and therefore it is a lot more better, I guess, in terms of data. But it's only started about a few years ago, so if you can't do that much of time series analysis if you really wanted to, and if that's of interest to you. But there's also SAR data. And I'm not going to go into SAR because that's a super other complicated topic for a super other time. But SAR stands for Synthetic Aperture Radar. And it's actually taking into account radar data and smushing it to create an image. And normally it starts with a area disturbance point cloud, and then it goes into a variety of different processes to then produce an actual image. SAR has its uses because it can actually cut through clouds, right? So clouds are no longer a problem, but you're not going to be able to see images as clearly or as optically nice as what you see on the right-hand side here, which is with this solar tower. That's not what SAR is used for. SAR is used for a variety of other tactical needs, but if you need it, it's there. And then ISRO has a ton of data too. And I'll be the first one to admit, I think the Indian government could certainly use two things. One, can you please start making HTTPS a normal thing? Because they don't. But otherwise, Bhuvan, which is this geo platform that ISRO maintains through NRSC, might not be the sexiest looking website, but it's got a lot of data here. And chiefly, there's a variety of data products with a really good definition set and a resolution set that's available to you as well. So you kind of just go here. I think you just Google Bhuvan NRSC or Bhuvan ISRO, and you'll be able to get to this. I think working with NRSC sometimes can get a little tricky. You do need to get explicit permission from them. Normally, they're pretty cool about it, especially if you're an Indian national. But that's just kind of let you know that there are lots of data sets available to you, everything from snow cover in the northern parts of India to cropland data sets to forest fire things that occur, all the stuff that we talked about. Maybe it's at more coarse resolution, but it's more easily accessible to you as Indians. And that's kind of all I wanted to talk about. So if I was to end this, I just wanted to say thank you for having me. Thank you for hosting me. If you've got any questions, feel free to, ask me after this talk, or if you think of something 2 days later, that's my Twitter handle. I don't tweet once, sorry. But if you want to just DM me, I'm happy to just take that as well. So thank you.
Yeah, thank you, Deven, very much for the talk, and it was fantastic. So yeah, I think we got some questions over the YouTube live chat, so I'm just gonna shoot them to
Sure.
you. And yeah, so we have first question from Shaksham Arora. The question is, does Planet develop these cube stats, or are they just used for data collection?
Does Planet develop these CubeSats, or are they used for data collection? I'm not sure if I fully understood that question.
So I think this question was posted in the beginning of the presentation.
Okay.
So maybe it was something related to some satellite.
Yeah, so if I was to try to explain this, Planet is vertically integrated, meaning we design our satellites literally from a space system standpoint. We manufacture our satellites. Not all of the components, of course, are going to be built in-house. We take as much of it commercially off the shelf as possible. We design them, we build them, we launch them. The rockets are not Planets, clearly, because you saw a SpaceX rocket. But everything outside of the rocket and the cloud compute provider, which is Google Cloud and Amazon, we maintain and manage ourselves. And so, yes, the mission is to do data collection. We don't build satellites for other customers, if that was maybe the question you were trying to ask. We purely are a data business. And so we had to build a massive backend, and for us, a backend meant going to space, but it's a backend nonetheless. And our main commercial providing opportunity is on the data side. Hopefully that answered.
Okay. I think I think the question was a two-part question. Does Planet develop CubeSats, and are they used for data collection? So yeah, I think you answered it pretty
Yes,
much.
on both.
Yeah. So like coming to the second question, so we have Nitin Hamesh. So the question is, how much they use open source projects, and if someone wants to contribute to their open source projects, then how do I do that?
Sure.
Assuming they Planet Labs here.
Yeah. So from an open source standpoint, Planet is a massive proponent and champion of open source. In fact, most of what we do wouldn't be possible without the advent of open source data already available to us. And so we like to think that we are standing on the shoulders of giants that came before us. So from actual libraries and frameworks that are available, we have a engineer at Planet, which is kind of a very not so nice way to call him that. We have a very bright, very awesomely smart person at Planet. His name is Frank Warmerdam, and he actually originally created the Python library called GDAL, Geospatial Data Abstraction Library. It is used pretty much by anyone in geospatial. Google Earth Engine on the back end uses GDAL. Bing Maps uses GDAL. A variety of other sources, commercial or open source otherwise, use GDAL. QGIS, which is that tool that I told you, almost entirely runs its raster stuff based on GDAL as well. Frank works for Planet, and we actually have a contractor that's paid through the Planet Engineering Organization outside of Planet that maintains GDAL, because we believe that it is really important that people have the ability to use as much open source software out there as possible. So FOSS, super important to Planet. On the other side, we have a lot of frameworks on the client side. So OpenLayers is one more that we don't actively maintain as much anymore. We let the community maintain it, but it's really great from a front-end standpoint if you want to be able to layer different kinds of geospatial data, not just imagery, even vector data, in order to be able to create nice, good front-end applications. And so a lot of Planet engineers actively work towards maintaining OpenLayers. If you were to look at the GitHub commit section and commit rate of OpenLayers, you'll see that either the top or one of the top two contributors to OpenLayers is also a Planet employee with like millions of commits. So like it's very much a thing that Planet believes in. And if you'd like to contribute to it, please feel free to do so. We don't try to mandate that.
Yeah, definitely. So yeah, so we have another question from Sukesh Perla. So the question goes like, are there raster files or vector files that they produce open to all for consumption?
So Planet.
So I'm thinking it's something related to the. Yeah. Please go ahead.
No, go ahead. Sorry.
So I think the question is, are there raster or vector files that they produce open to all for consumption?
Yeah. So the way to think about this is all of the imagery that's produced is almost always going to be raster. Yes, there's a way to vectorize it and a whole bunch of other stuff, but normally, let's not get into that. A lot of the analysis that we do for now is raster as well, but is going to go on a path to being vectorized. Some of the analytics that we provide in terms of object detection, object localization within our imagery, that's vectorized for sure, because this has to be vectorized because it needs to be queryable, indexable, and something that's completely not attached to the imagery in any way, shape, or form. So that's kind of how Planet produces imagery. In terms of being able to openly be accessible to all, Planet is a commercial provider. While we have a free trial, it's only going to provide you raster satellite data for a small time period. If you need to get any analytics data, that's going to be something that you need to pay for. But Planet stuff is interoperable so that if you have geospatial data that's vectorized or raster, it can just work.
Yeah, all right. So, yeah, so we have another question from Akhil Teja. The question goes like, what scaling methods are used for calculating distance between point on satellite images?
What, could you repeat that question again?
Yeah, sure. So what scaling methods are used for calculating distances between points on satellite images?
Oh, yeah. So in general, what we actually try to do is, if we're going to try to do any kind of orthorectification, which is the procedure used to understand distances between not just 2 points, but actually able to orient the imagery into a right 2D projection, we use a series of ground control points. That's what is the terminology used in geospatial world, that we've both acquired from other sources and we've made in-house as well. And that kind of helps us understand, spatially speaking, how to orient our data. And then when it comes to actually producing the data, scale representation is actually a fairly easy problem or easy thing to do. So like most modern geospatial systems and solutions out there, as long as you put a good map projection and all of your data is in one map projection. So we recommend Web Mercator if you're going to do anything on the internet, then spatially speaking, pretty much everything is referenceable in a fairly automatic manner. So it's almost as simple as like scrolling in and out or zooming in and out on Google Maps.
Awesome. So I think there was another question like by Akhil Teja, like are Planet images free for developers for educational purposes? So I think you did answer in the slides in the presentation.
Yeah, so there is a second thing that I didn't mention, but maybe it is now worth mentioning. Planet does have an ENR program, an education and research program. So if you work at, or if you not work, but if you study or work or have a PhD candidacy or are doing something at a degree granting university around the world, right? So it's not just in America. You are eligible to apply for an education and research program license with Planet. This lets you get access to a decent chunk of data, certainly more than the free trial, of course, and it lets you get it for a time period that matches the duration of your research. So it's not like it's time bound to 90 days or something like that, and you need to like spend a lot of time to download as much of it as possible. It like matches the time period of the research activity or work that you're doing. And then the only two stipulations are you can't do anything commercial with it. So you can't turn it around, go build a startup, and then start selling, derivative products. And the other thing is, if you're going to publish a paper, which we encourage you to do, because we love those citations, I love them, baby. Just please bring it to us first. We'd love to be able to peer review it and just make sure that the way you've represented Planet data is accurate. If we can provide feedback, we'd love to be able to do that. And we have a very strong education and research team at Planet that would love to be able to help you out. So that is totally possible. The best way to access it would be just Google Planet Education and Research. But if you go to planet.com, you'll be easily able to find that ENR page.
Yeah, that's great. I didn't know that. So thanks for mentioning.
Yeah, for sure.
Yeah. So we have like another question from Ankit Agrawal. So it goes something like, do Planet exposes any of its APIs endpoint to the public domain? But I think you also answered that. So if you want to add something to that, that would be wonderful.
Yeah, so there's two nuances I'll add there. In terms of API documentation, that's not hidden. That's available to everyone. If you go to developers.planet.com, like we make our API endpoints super easily accessible. The API key normally comes whether it's through a free trial, an education and research program, or through a commercial deal. And so we don't really let you have easy access to the API unless you fall into one of those three categories. And frankly, we need to do that because like there's a lot of theft and abuse and all the whole bunch of stuff that occurs. So we need to be able to make sure like we don't have some random publicly accessible API that's hanging out there. But the documentation and reference for the API is public to everyone, as it should be.
Yeah, definitely. So yeah, we have a lot of questions coming from you. So I hope you are ready for that. So we have another question from Ved Prakash. It goes like, what different concepts in book should I refer to process satellite images?
What different like literature pieces that he might want to use
Yeah,
in order to
yeah,
work with
like
satellite imagery?
books and the book references or something like that.
So there are. So I'll give you a personal story, which can kind of hopefully answer this question. 3.5 years ago, when I came to Planet, I knew nothing about geospatial data. I knew nothing about satellite imagery. Frankly, I was working with a variety of e-commerce companies in the Bay Area to help them sell pants more effectively. So like when I came to Planet, I had no context and no idea how to work with any of this stuff. What helped me pick up as much information as much as possible was twofold. One, which unfortunately you might not be able to get, sir, which is access to employees at Planet who are super smart and well-known and well-renowned within the geospatial field. So sorry about that. But the other thing that is absolutely easily accessible to you is a variety of documentation related to geo-related things. So there's an organization out there that handles conferences called Phosphor-G, FOSS with the number 4G for geospatial. They have a variety of resources that are available to you. If you would like, there's also a series of tutorials that are on the Planet developers portal, which can kind of get you started with a few things here and there. But if you really want to dive into things, then I would see if your nearest university has a geography or a geospatial program, and that's probably going to be the easiest way to do it, because while you don't need to enroll in coursework, you will find someone who will be able to better help you work with that stuff. And then of course, as you're getting into the stuff as any software engineer, Stack Exchange is awesome. So the GIS Stack Exchange is super helpful with a lot of resources and a lot of stuff out there as well. So it is pretty easy to do so. I don't have books off the top of my head that I would recommend. Maybe O'Reilly's Simple CV book, which can better help you understand how to do computer vision related activities on geospatial data. But outside of that, I'm not 100% sure if I could accurately recommend to you any books.
No, I think that was super useful for the person who just asked the question. So yeah, so we have another question from Parv Bhutiani. It goes like, what kind of engineering stack is there to process the data? Data means satellite data.
Yeah, I mean, for the most part, it's CPU intensive, right? So if we're to talk about the infrastructure to process this data, there are a variety of different procedures. First, actually, you know what? The orders might have changed, so let's not assume this is in chronological order, but at least these are all the steps that need to be taken. So as soon as the stuff comes down to the ground, it has to go into a giant data lake, right? And not all of the information and metadata is actually legally allowed for us to redistribute to everybody else, because it is important information that the US government has deemed only we get to know and only they get to know and nobody else gets to know. And it's just like metadata more than anything. So then we migrate as much of the geospatial data out from GovCloud into the public cloud. And at that point, a variety of procedures begin. The first procedure is just to make sure, or one of the procedures, I should be clear, is just to make sure that you can actually process all the data, uncompress it from JPEG 2000 to an actual raw GeoTIFF format. Then there is infrastructure put in place with that same job system to let you understand how to rectify imagery based on the ground control points that I mentioned earlier to spatially orient all the data. And then eventually it is to make sure that you can actually publish this data in a queryable manner. So on the very back end, you've got a data lake, which is just a giant bucket. Then you've got a series of compute infrastructure bits that I probably can't go into that many details. Then the catalog is basically a giant Elasticsearch cluster, which indexes very frequently to make sure all of our data is as accessible as possible. And then the APIs are basically just running on a series of either like Go-based services or JavaScript-based services.
Oh, yeah, great. So we have question from Manoj, and Manoj is on the live chat. So I think the question is pretty long, so you can directly read it from the live chat if you can. Let me know you can read the question.
Oh, yeah, I'm happy to read it. You might not want to listen to
Yeah.
me read, but I'm going to do it anyway. I read about Planet. Planet wants to differentiate itself by building a layer of image recognition that can be applied to its photos. If we can recognize ships, cars, boats, planes, houses, and roads, then we can turn all of this into a database of what's on the planet. That looks so exciting. How is that coming up? So I guess to answer the first portion of your question, Manoj, that's kind of thematically speaking, and this is not a product in any way, shape, or form, but thematically speaking, mission of the company now that we've been able to image the Earth on a near daily basis, or at least landmass and some parts of the water, is to make sure we can index the Earth as much as possible, right? And so the theme that we use is queryable Earth. And that's a thing that our CEO Will really wants to, champion forward. And a lot of it starts with the nascent analytic feeds that I talked about, so road detection, building detection, but it also happens to do with ship detection, which is a publicly available commercial feed that we offer. There's also industry-focused feeds that we've created. So for the oil and gas industry, there's a well pad detection because a lot of on-ground exploration of oil activities occur, and so we need to be able to spatially be able to detect those activities. There's deforestation-related alerts that we've built out for a few customers as well. But the most important thing, if I will, is as we want to create this queryable Earth mission, we know we're not the only ones that can do it. And frankly, we don't have the bandwidth and capacity to handle every problem out there. And so we created this ecosystem program called Planet Orbit, which is, yeah, it's a cute name, but basically it's a variety of companies, institutions, research facilities that can get access to planet data at slightly more subsidized rates so that they can build those derivative analysis products. So we've got everything from people who are monitoring the oil storage tank levels around the world to people who are monitoring, like with 3D reconstruction, coal piles to understand energy impacts and needs, to people who are monitoring electric utility rights of way in order to understand if the tree canopies are coming close to the power lines to make sure that you can cut off those tree canopies before a large fire occurs, which definitely hits us close to home because if I just look up from my window at the San Joaquin Mountains back there, we had a wildfire here that was primarily related to utilities not managing their trees infrastructure well, right? And so like this is all part of the queryable Earth theme. Some of it, when we say we, is the we as planet, but most of it is really just we, the royal we, all of us. If we can all have the capability to recognize ships, cars, boats, planes, airplane detection is also a thing that we offer. Sanket, it seems there is a second portion of that question. Did you want me to read that as well?
Yeah, please.
Okay. What is one or a few open source tools from the Python data ecosystem, maybe for data analysis, image analysis, and that you heavily use at Planet? So the two big things that I'm going to mention are GDAL, GDAL, and OpenLayers. So OpenLayers, I would say, is more on the front end side of the situation, and GDAL is basically the backbone of pretty much all geospatial work that we do at Planet. We're lucky that Frank happens to work at Planet, but at the end of the day, like that is going to be the library that I'm going to mention as my favorite because a large part of stuff that I do, whether it's composite or just getting metadata information from a geotiff, like all that stuff is super easy with GDAL. It comes as a CLI tool as well as a series of scripts that you can use inside the framework in order to be able to do a large set of activities in a both serial manner or a batch manner, however you need to work with your data sets.
Yeah, great. So we have just 2 questions left for you, and we're gonna, come to them. So the question goes from Manav Sethi, and it goes something like, "What are the common pitfalls, fail safes Planet Labs implement?" Let's just say if the data doesn't come back at all from the satellites.
The common fail-safes. Well, so I guess there's the most abstracted fail-safe and redundancy. So if you want to think about it this way, the most common fail-safe that we have is the fact that we have hundreds of satellites, right? Historically speaking, remote sensing missions were satellites the size of a giant bus, literally like a bus. And they took 7 to 8 years to build, maybe another 2 years before they could get a launch provider, and then another like 6 months before it gets commissioned, and then you finally get access to some data, right? And then imagine the amount of technological progress that happened between the time you designed that satellite to the time you actually got it to space. Like especially within the last decade, like the amount of improvements to storage that have occurred within our own satellites has been insane, right? So we started with a pretty okay radio with pretty decent downlink to now we have the fastest radio like for any satellite out there, with the exception of maybe the Starlink satellites. But it's basically a 2 gigabits per second 6-channel radio. Like that shit is faster than my internet connection at home, right? And while the latency might be in a couple of hundred milliseconds range because it's space, like that is an insane amount of downlink speed. So a large part of the way we build in redundancies is to make sure individual components inside the satellites get improved over time and can actually reduce the amount of needs for fail-safes. And then in general, because we have 200 satellites, like we don't care. I mean, yes, we do, but we don't get negatively impacted that much if 20 of our satellites go down and our company's basically gone to shit, right? Like, and that is a very real situation that occurred about a couple of years ago when the sun, because the sun is unpredictable and no one knows why it works that way, but basically did a corona mass ejection event where it flew out a large solar flare and a large amount of solar radiation came right past the Earth and right through the Earth. Or not through the Earth, but right around the Earth because we've got a good magnetic field. Unfortunately, not all of our satellites survived that solar radiation event. And so 20 of them actually went down. And that was okay because we replenished them pretty freaking quickly. And so that's kind of one way to think about redundancy at an abstracted level. And then inside our internal systems, like our job system that I mentioned, and even within some documentation that you'll see on the Planet developers portal, you'll notice that we have a retry system built in place. So if a job fails on our side, the retry system just kicks it right back into the queue and gives it like 3 or 4 more chances to be able to run that job again. And then at that point, if it fails, then we'll notify an engineer and say, hey, like these 30 jobs failed. We tried to do them 4 times and it didn't work. Sorry, right? So that's kind of the way I think about redundancy, both in a hardware setting, software setting, and a kind of an abstracted like mission setting.
Yeah, awesome. So that was a very good answer and well explained. Thank you for that. And we have the last question right now. So it goes something like, "What are by Shreyas Piplani? So are there any projects that Planet Labs has taken in India, or in collaboration with any Indian companies or startups or organizations?"
Yeah, for sure. In fact, I'd say there are 2 or 3 states in India, Maharashtra for sure being one of them, and I don't know the other 2, that actually subscribe to Planet Data with getting approval from NRSC in order to monitor vegetation across the entire state for all of their smallholder farmers. So like in that context, we've worked with both government institutions as well as certain small private entities in India. With ISRO, I think we're trying to be a much better commercial partner. We definitely obviously have a one-directional relationship from us to them in the sense that they launch rockets for us, or they launch satellites for us on their rockets. And we love working with them. They're one of our biggest launch partners. But I think the NRSC also at some points in time was interested in acquiring Planet Data. I'm not sure where that's landed, and I'm not sure where that's going, but I know that there was interest. And certainly from a dialogue standpoint and from a willingness to work with people standpoint, like Planet's super up for it. And we hope to, sell more of our data to more people in India.
Yeah, awesome. So I think like that's the end of the questions. We do have like few questions, but I think it's about time. And we have some questions in the YouTube chat. So if you want to answer them, you can directly look over there. And so yeah. And I think like we are done with the talk. And thank you very much for coming, Devin. It was so super fun to have you. And I guess the audience learned a lot. I'm getting constantly messages from all the people from the community all over the world that the talk was pretty exciting. And yeah, that's great. So yeah, exactly. So we also have like a quiz, rapid fire quiz. Prepared for all the audience. So if you want to hang around for that, so please be my guest. We have pretty simple questions. So yeah, that's good. And we're gonna switch to the quiz right now. And so yeah.
Sounds good. Happy to be here.
So yeah, I think everyone can see the leaderboard over here. You can just go to menti.com and use this code, and you'll be logged into the uh, questions of the leaderboard. And I would advise all of you to use your Twitter handle for the username on this quiz menti.com, because we will be picking winners and we will be distributing goodies to them based on their Twitter handle.
Sanket,
Yeah.
I think we can also let the audience know about the tomorrow's talk.
Yeah, sure. Okay. So the people who have joined late, I just have a small announcement to make that this is day one for the 30th meetup of PyData Delhi. So we have like second day and second talk scheduled for tomorrow, same time, 21 9 p.m. IST, and we have Matthew on the call right now. So Matthew Seal, he works as a senior software engineer at Netflix. He would be talking about programmatic notebooks using Papermill. And so yeah, more of that tomorrow. And I hope to see all of you tomorrow. So please, and we also have a rapid fire quiz scheduled for tomorrow, so you can just go to that. You can also participate in that. So yeah, so coming back to this quiz right now. And we have like these dashboards. So I'm waiting 30 seconds or something like that for all of you to sign up on this quiz, and after that we're going to start. All right, so I see like a lot of players have joined in for the quiz, and it's pretty good to see that. So we're gonna starting with the quiz. So the first question would be coming up on your screens right about now. So the question is, what's the output for print bracket underscore name underscore square brackets 2 dots 1 4 square bracket parentheses? Okay, we can see the leaderboard now. So there's one more thing, like this is a rapid fire quiz. So as fast as you answer, the more points you get. So yeah, please take care of that. So this is a question that we have a string and we have to print the statement. So yeah. I see Sukesh is leading the leaderboard. Now coming to another question. What new feature was introduced in Python 3.8? The next question is, which library can be used to create base maps in Python? The leaderboard is going quite good right now. And let's see who's leading the leaderboard. Okay, only real MVP. Cool. I know this guy. So yeah. I see something. I think the quiz crashed. So if any of the volunteers, please check on that. Okay, sorry. It's working. It's working. So yeah, I think we are coming to the last question. And yeah. Okay, so we have a winner, only real MVP. Cool. Awesome. So yeah, please contact us through through our Twitter or Meetup if you want to claim your prize. We would be happy to give you some cool goodies over there. And yeah, I think this marks the end of the meetup. And so just before we exit the meetup and conclude the meetup, I have just like few announcements to make. I see a lot of people in the YouTube chat asking like, how do they volunteer for the community and how do they become the part of the community. So we have social medias all over the every other website, like Instagram, meetup.com, Facebook, Telegram, and everywhere. So please do go and follow over there. And there's a link to our Telegram community channel on the YouTube live chat. So it's a pretty long link with some gibberish, with some text with some long text in the back. So you can click on that link and join to our Telegram channel, and you can ask your questions over there, like how do you want to join, how do you want to contribute to the community. And we have like volunteers spread all over all over that channel, and anyone of us would be happy to pick you up and assist you in how to becoming the volunteer for the community. And yeah, once again, like this is a recurring meetup. We would be having the day second tomorrow at same time, 9 p.m. IST. So please join us tomorrow, and we have a very exciting talk tomorrow, and I would love to see all of you over there. And please spread the word over there. And the link is same as today. It's delhi.pydata.org/live. And we would be streaming live on the YouTube. Everything remains same. Like the questions would be put on YouTube live chat, and there will be a quiz. We have winners and goodies and everything. So yeah, I think that's it. And thank you all for coming. It was so pleasure to have you, and I hope to see you tomorrow. I think we should pause the live stream now. Harsh.